So looking at chapter 3, there we go, chapter 3. Okay. So I want to talk a little bit about MVC. Some of this stuff we've covered already. The different things that are kind of in chapter 3 talks a bit about, we're going to talk about the MVC architecture. We're going to talk about what are these domain routers, what's a repository. I'm not going to do too much with repositories this semester, but it is part of how he sets up the example application that we're going to be building. But it's kind of a layer between the database and the entity framework. Loosely coupled systems using dependency injection, and then talking about automated testing. This book does put a decent amount of emphasis on automated testing. Fair forewarning, I'm going to be pretty light as far as focusing on that this semester, just because that is a very deep topic, and it can get to be a relatively advanced topic of how do you actually test things with unit tests. So we're not going to delve too deeply in that. History of MVC. So as I kind of mentioned day one, MVC's been around a long time. A long time. Specifically, first place we find it, 1970s, working on a language called Smalltalk at Xerox. Now, specifically, you've probably never heard of the term. Probably never heard of that language, Smalltalk. Probably not heard anything about it, right? And it's not a language that we use anymore. But Smalltalk was one of the first languages to have classes. One of the first languages to have classes. So what does that mean? Well, again, it's back in an age when those originally came up, when that was a relatively new idea. When breaking things into classes was a relatively new concept. And as such, well, MVC inherently kind of assumes that you have separate classes, right? You assume that your models are separate classes, your views are classes, your controllers are classes. So a lot of things have changed. Obviously, the world there, when we were working with GUI, sort of GUIs along that side, things were a lot more stateful, right? The world of the internet is what we call stateless. Have you heard that term before? Saying that the world is stateless, internet stateless. What we mean by that, the HTTP protocol at the base, if you come back and visit the website again, it's inherently got no idea that you've been there before. It doesn't know anything about your history. It doesn't know anything about whether or not this idea of being logged in or logged out. It doesn't know about shopping carts. It doesn't know about any of this stuff. There's no state, right? Inherently, the internet has no state. Obviously, we have ways around that. We've put ways around that to make applications that have state, per se. But the protocol underneath it is stateless, right? So anytime you want to go visit the website again and say that you're logged in, well, every time you go visit the page, you have to tell them, hey, I'm logged in, here's my information that proves that I'm still logged in, right? If you don't give it that information, then it assumes, oh, you're logged out. So, MVC is broken up into 3 parts. First part being the models. So the models are the place that we store data, right? And which we've seen in the example we just went over, where did that model come into play? We're not actually saving it to disk. We're not actually storing it in a database yet. But what were we doing with that model?
That contains the properties that the site needs to use.
It was for the RSPP form, right? It was the data we send back and forth, right? So it's kind of a representation of what the form looks like, kind of an abstract representation of what the fields are on the form. So we can send them to the server, and then the server can send them back. Does that make sense? So that's one part where we'll see a model, right? We'll also eventually save that model to the database. We have the views. The job of the views is provide that presentation logic to the user, is to actually show the data to the user. That's all it does, right? So what we put in the views isn't making any changes, right? It's not actually performing any actions, it's just showing the data that we have to the user, right? And then we finally have the controllers, which is where we're going to put the business logic, all that glue, all the actual logic of, okay, the user wants to do this, let's make sure they're giving me valid data, and then go do it, right?
So if you were to make like a calculator app, like where would the actual doing the math be?
Right. So there's a few ways to structure that. So my first option, I have two kind of ways I could structure a calculator. One option is I could do it entirely front end. I could do all the logic in JavaScript. I could write the calculator all in JavaScript. I would generally recommend that's usually the best way to write it. If you're going to write it for a website, write it all in JavaScript. Well, at that point, it's basically all in the view side, right? Now, let's say you want to do it with a little bit more MVC sort of thing, right? Well, what would be the model? What would the model be in terms of your calculator? Well, it would be what's currently entered on the screen, right? You would be, if you have number 300, that's the number that's on screen, right? And it might be 300, and oh, by the way, you've hit the times key. So it might represent a number and an operation, right? That's kind of the current state of the application. So you say, okay, I've got a number, and I've got an operation, may or may not be there. So I type in, I hit the number keys, that's going to send this, that's going to change that number, and then eventually I'm going to hit one of the operations, plus or minus, and then so you send that to the server, it'll come back and show it to you, yada yada, back and forth. So what's kind of shown in the screen, those kind of bits would be your model. Your view is how it looks, all the CSS and HTML and whatnot that goes in to make it look pretty. But then your controller, that's where you'd actually add up or multiply numbers. That makes sense?
Yes.
You do the actual calculations in the controller. The model just stores what the current state of the application is. Right. Any questions? Does that make sense?
Yes, that's what I was looking for.
As far as breaking that up?
Yeah.
So let me ask you on that. Let's say I wanted to save that data I wanted to save the calculator info, the current number that you have on screen, to a file. What of these three parts should be responsible for saving it to a file?
You said it again.
Let's say I want to save the number. Let's say your current number is 512. Where should I actually save that to a file? No.
Or no, save it to a file.
If I want to save it to a file, where should I initiate that? Where should the code for how to do that be? The code for that should be in the model. So the model is the logic for how to save it, how to persist it. What you will see in the controller is one line that says save the model. That's it, right? You'll see in the controller one line that says go save it, but the actual logic that does that should be in the model. Does that make sense? So because the controller dispatches everything. Pretty much if we're going back to console applications, it's our main, right? It's where we have the main part of the application, but the actual logic for writing the disk, writing the database is going to be over in the model. Okay, that's an important job that the model has, is persisting data. We never want to be persisting the data in the controller itself as much as we can avoid it. Even though oftentimes we'll have to initiate that operation or tell it what to save in the controller. One word on models. So these models we often refer as domain models. What do I mean by domain? Domain, I mean what kind of thing is the company, what's the domain of the company that you're working for? What is the application about? What does it deal with, right? So let's say I am building an e-commerce site, a shopping site, right? What kind of objects would you normally see on an e-commerce site?
The items.
You would see products, right? You'd see customers. What else?
Prices.
Well, prices aren't really objects, they're properties, right? So a product has a price. So you have products, you have employees. Or, sorry, products and customers. Don't I eventually need to buy something? What do I usually call that when I buy something? I call that an order, right? An order is hey, I want to buy something. So common items that you'll see on any e-commerce site, you'll see products, things I can buy, customers, people who want to buy that or are interested in buying it, orders, which saying, hey, yes, I want to buy this. So those are three common domain models that you would see in an e-commerce site, right?
And so if they wanted to do stuff, they would be in control, right?
What do you mean?
Like the methods to like actually check out.
Right. So what I might see in the controller? Well, I might see in the controller, will probably have, for every model I have, I generally end up with a different controller. So I'd have a product controller, I'd have an order controller, and I'd have a customer controller. That'd be pretty normal. Or that customer controller might actually be a user controller to be more general, right? So in the product controller, well, what kind of things do I need to do with products more often than not on a shopping website?
Update inventory.
Huh?
Update inventory.
Assuming from the customer side. Assuming from the customer side. They need to be able to search, right? So I might see the index on my product controller is probably going to be my search page, right? That main page for products is going to be, I need to be able to search for products, right? The next thing is going to be, I need to find more information about a product before I buy it. So I might have an index page to give me a search. I might have a details page to give me information about a specific product. If I was an employee, yes, I might have an edit page, right? I might have an edit action on that controller to be able to edit the details. But as a customer, I also may want one to add to cart, right? So I might have an action on the products controller that says add to cart. Now, here's a question. If I'm saying add to cart, maybe I don't necessarily want to put it in the product controller because I'm not actually doing anything directly to a product, I'm doing it to the shopping cart, right? So I might actually say add to cart, I might actually put that on the cart controller of some sort, right? Even though maybe the cart doesn't have it may or may not have a domain model, I might still create a cart controller, right? So that's things you might see, right? You might see orders, you might say add an order, edit an order. You might say, okay, well we shipped it, so you might have you might have an action method that marks it shipped. Customers, what do you need to be able to do as a customer or a user? What are some of those options that you need to be able to do as a user on a website?
Log in.
When you log in,
Get things shipped to you. So like setting up your account.
so you might need to register. You might need to edit your account, right? And sometimes the edit is broken up actually into a bunch of different parts. So you might have one that edits your like public profile information. You might have another one that edits your email. You might have a third one that edits your password. Just for security reasons, we don't usually put those all on one page. Does that kind of make sense? So there's going to be a bunch of different controllers. Roughly every model object that you have is going to have its own controller, and every controller is going to have a bunch of views. Now, the reason we call that, let me be clear, domain model. So that's for e-commerce, right? So we have those objects for e-commerce. What might that look if I'm saying, well, I'm making a wiki about some video game? What kind of domain objects might I see there? Let's say I'm making a wiki about Shovel Knight.
You would need pages.
Pages for sure.
Like pages that can be edited.
Okay, so there's pages, potentially.
Like, oh, some kind, trying to think, like, would explain it, like the...
Could those
page-
pages
would be
also
able to
have
dynamically
comments?
add them. Yeah, comments maybe.
Right? Might I again have users because somebody wants to change those?
Yeah.
So again, I'm probably going to have users on nearly every website.
Yeah.
So users, pages, comments. I might also want to upvote, downvote, like things, right? So I might have some sort of rating object that tracks this user gave this page 5 stars or whatever, you know. I might have some objects as far as sharing, if you wanted to share these things in social media, to track those kind of things as well, right? So depending on the kind of website you're building, right, the domain model is going to be very different, right? And oftentimes that's when we're building and designing a website, that's usually the best place to start, is to figure out what is that domain model? What are those things that map up to kind of how things look in the real world, right? So oftentimes those are built together with the business, together with whoever your client or your manager is, or whoever the business analyst is, to kind of figure out what are those things in the system that we care about as a business, right? So that domain model is going to be very different depending on, again, what kind of application you work with. But we start with that. Okay. The way that ASP.NET kind of influenced the MVC architecture looks like so. So we're going to start with when you send in a request, when you ask for a page or you submit a form, it's first going to go to the controller. So based on your URL, if I'm posting to product edit, right, it's going to go to the product controller and look at the edit method, right? So it's going to send that information to the controller. That controller is then going to go get more information from the model, which may come from a database, may fetch information from a database or a file or whatever way we want to persist it, right? So that controller is going to go out to the model, get the data, it's going to come back, and then eventually it's going to send that model onto the view, and the view is then going to show it to the user, right? The view is going to figure out how to turn the data that we got back into something user-friendly, into an HTML page for the user. Does that make sense? So every time you load up a page, every time you submit a form, this is the path that it has to go through. Does that make sense? Oftentimes in more advanced setups, this trip between the controller and the model happens a lot of times. So we may have to fetch more data from the model, so we may have to make more than one trip to the model to actually get the data. Okay. But there's always only one trip in, one trip out for when you visit a page. So, how does MVC compare to some other patterns? And this is relevant. One of the things that you have to know about MVC, like I kind of mentioned on day one, it's not really going to hold your hand and enforce this should be here, this should be here, this is how you should do it. it's a very, very flexible system, right? You can call the controllers wherever you want. You can call the action methods wherever you want. You can call the models whatever you want, and you put the code in any of these 3 places more often than not. So it does take a healthy amount of exercise to kind of figure out where should things go. Now, one of the things that often happens, if you're not careful about where you put things, you start putting everything in one bucket. And you start finding that this one particular part of your application now has all the code. Whether it be, okay, I put all the code in the model, or I put all the code in the view, or I put all the code in the controller. It's not uncommon for that to be a problem with MVC, where you find out that one or two of your layers is very skinny, there's barely any code there, because you bundle all the code in one other place, right? So the ideal is, hey, there are cases where there's going to be a lot of code in some places. In fact, it's not unusual for the controller to have a lot of code in, to be honest, and that's okay, because it's where our business logic goes. But you kind of have to watch that and just see that everything's in the right place. Because as you start shifting away from putting it in the right place, you'll shift into some of these other patterns of development. So the first sort of pattern that's kind of related to this, and is just the simple basic pattern, okay, is what we call the SmartNew pattern. It's kind of what I would actually call an anti-pattern, because you really never want to do this. But this is where most of you started. This is probably where most of you started when you first started writing JavaScript, or especially when you started writing MVC forms, right? Where you said, okay, respond to the user doing something, put all of your logic in the handler, and then, okay, now the user sees what you did, right? Where all of your code was in that event handler on your form, right? So now I have one giant form where all the code is in that form, right? That becomes pretty quickly unwieldy, because, okay, so now where do I find things? And what happens if, okay, I've got duplicate code, right? I got to start breaking things off to avoid duplication, right? That makes sense? So Smart UI is just, hey, everything's in the UI, basically. There's no separation between views, there's no separation between controllers, there's no separation between any of that. That would be effectively you just have a view and nothing else. So this is typically how you would have started with Windows Forms. Okay, now let's break it up a little bit. Now we say, oftentimes when you start saying, well, oh, I need to write stuff to a file. Okay, I need to save the data that's on the form, right? Well, now I need to create a way to model what needs to be saved, right? So then we jump out and we say, okay, well, I'll take a little bit of this code out here, define how I'm going to store my data. We'll call that the model, but we'll still keep the rest of the data over here in my event handlers and my UI that does all the magic for the actual application. So saved a little bit. Another way to start breaking this out, it's not too different than what we just saw. We say, okay, well now I'm starting to get more logic that has to deal with how we write it out to files. Maybe I need to split that off into a separate layer, especially because maybe on some computers I need to save it this, for some of my customers I need to save it this way, and for some of my customers I need to save it another, right? Or maybe I'm shipping this app and I'm shipping it as a mobile app and I want to run it on iOS and Android. And so the way I save files is different between the two. So I shoved it in a data layer and I say, okay, well here's the data layer for iOS, and here's the data layer for Android. And now I want to support Windows Phone. Okay, so I make another data layer for Microsoft. Okay, so I have a bunch of different versions of the data layer that just deal with saving files, right? So you might break that off. We still keep the same model, because even if I'm saving off Android or iOS, I'm probably saving the same data, even if the actual code to save it is different. That makes sense? Same thing happens if I'm trying to use a different database, right? I might have one data access layer here that works with MongoDB. I might have one version of this data access layer that works with SQL Server. I might have another version that works with MySQL, right? So break that off, okay? So the model, those should stay the same. The way I represent the data should stay the same, regardless of how I'm saving it on disk. But then we still keep UI as all the actual logic for our application. Okay? You'll see this in a lot of applications that you see in the real world. Okay, so let's break that up a little bit further. Another variation, another pattern that we see out in the field is something called ModelViewPresenter. Okay? ModelViewPresenter and ModelViewController are not the same thing. They sound very close, but they are not the same thing. So, ModelViewPresenter. So, in ModelViewPresenter, model is just like we've been talking about. It's the part that saves the data, that models the data we want to save. The view, in this case, would be the actual controls. The actual controls that you have in the view. Okay? The presenter now is this kind of abstract thing that in theory you've extracted. You've said, okay, well, I don't want to put all my code into the form class. I want to actually break it out into this presenter object, which then maybe I can use for more than one application or something.
Are we going to use any of these things in the list, or
No, we
kind
would
of
be.
just like filler?
Yeah, we're just explaining background, other design patterns that exist, right? The whole goal of this is to say, what are the other patterns that are out there that are similar to MVC? One of the reasons you want to know about this is these are very common, like, interview questions. So understanding, what is ModelViewPresenter, what is ModelViewViewModel, what is MVC, and how are those three different is a common thing that an interviewer will actually ask you, just a fair forewarning. Because it's a thing that we work with a lot. And understanding those little nuances between the different design patterns is kind of an important thing. That makes sense? Because it does have a big impact on how we structure our code. Okay. So ModelViewPresenter, the idea is you kind of extract what's inside of your form and you put it out into another class, right? And you call that the presenter. Now that presenter is usually tightly tied to both the view and the model, right? And in fact, there's usually, in most setups with presenter, there's an expectation that there is state, right? There's usually an expectation that the other parts are stateful, that the system is stateful. Now remember, we talked about this just a minute ago, is HTTP stateless or stateful? Stateless. And that's a really big deal, which means that ModelViewPresenter hardly ever is a good idea when it comes to building websites. Okay, it might work if you're building a mobile app. It might work if you're building a desktop application. Both of those are stateful sort of applications, but it doesn't work very well in the web development sphere. Another pattern that we'll see out there is something called ModelViewViewModel. Okay, this is actually what WPF is built on top of, is built around. And it's this idea that you have the model, which is the actual way we're going to save the data. We have the view, which is how we're going to show the data. But then we got something in between we call the view model. And the view model is where we kind of change it up a bit, so, well, because oftentimes the way you see it on the UI is not necessarily how it's stored in the database. Make sense? So we kind of put a layer in between there and say, oh, well, I also need some data for what's in the drop-downs for this page, right? So that's a common thing that would get added into the view model. In fact, you'll see view models used a lot in MVC. We still use view models because they're still a helpful concept. Because oftentimes how we save the data is not necessarily gives us all the data that we need for that particular page. So we may need to build a view model specifically for a page. So you'll still see view models. The thing about view models is they're never saved. You never save a view model to the database. You save a model to the database, you never save a view model because then it's an abstraction of what we're actually saving. Does that make sense? It's a different restructuring of how we're going to actually save the data. Okay. Any questions on those patterns at this point? I would recommend reading through that whole section. Your homework 1C has some questions about it. So you want to go through and answer those. Take a look at those. Yep.
Is the homework just chapter 3? Is it the last 3 chapters?
So 1C will be 1, 2, and 3.
Okay. Is that what the test will be too?
The test will be over chapters 1 through 6.
Oh.
Your written test is going to be over 1 through 6. So, does that mean that not everything in 1 through 6 will be on the written test? That would be right. Not everything in 1 through 6 will be on the written test, but there will be probably something from each of those chapters on the test.
I know, like last semester, like we study our homework a lot for the tests.
Yeah.
Does
I would still recommend that. The written test more than likely will be a subset of what's on the homeworks for chapters 1 through 6. So, yes, that would still be a thing I would recommend. But yeah, there will only be one written test. It will be a conglomeration of all that. So, loosely coupled components. Oftentimes one thing that happens, and this is where, don't worry about this too much. This part for the rest of chapter 3 is a bit more an advanced topic. It's largely revolving around testing. How do we test something? There is more to it than that, because we may still use these techniques even if we're not designing for testing. Dependency injection is still a good tool, even if you're not trying to write unit tests. But it is a must if you want to write unit tests for your code, which is going to be, hey, I want to write code to test my code, right? The nice thing about writing unit tests is there's something that we can set up to run every time one of the developers on the team commits code. So we can say, okay, anytime anybody commits code, run our full suite of unit tests. If any of them pass, now we can send you a nasty email and say, you broke something. Rather than waiting a few weeks and find out, oh, now it's in production or whatever, and now users can't edit this, or they can't log in, or they can't, whatever it may be, that something's going wrong in production. So we'd like to have those off early. So that's where that comes in. So a common place where we have these kind of interactions, if you think about how our classes are structured, oftentimes you can think of them sort of as a tree going down. So you have kind of here's up at the top, the main, the controller, it talks to some things beneath that, that talks to some things beneath that, that talks to some things maybe at a lower level. Ideally though, when we test things, we want to test it as just one class without any other classes connected to it. Ideally, we want to test these classes in isolation. So that's where we say, hey, for instance, maybe we have this idea of something that can send emails, right? So I make an email sender interface, and we can say, okay, well, the password reset helper needs to send emails. If you're resetting your password, I need to send emails. If maybe I'm registering for an account, I maybe need to send emails as well, right? So sending emails is a common thing throughout our website, but ideally we want most of our code not to know the nitty-gritty of how we're sending emails, because it's not unusual to need to change that, if that makes sense. not unusual for us to need to move to another email provider. So we don't want that, those details like the username and password or what environment variables those are stored in. We don't want all that stuff littered throughout most of our code. So we use something called a dependency injection to kind of extract that out. Okay? So a normal setup to maybe writing this up, and you saw this, we did this with that SMTP client just a minute ago. Normal way to set this up, we might say, okay, well, we don't want to repeat all that logic that we have with SMTP client every time. So let's move that into a class called MyEmailSender. So MyEmailSender is now the only one that knows about SMTP client, right? Now, maybe I want to test it without actually linking it directly even to MyEmailSender. Because maybe when I test it, I don't want to send out actual emails. I just want to know that the proper methods were called, right? So I might say MyEmailSender actually implements this interface. That interface has a method called sendEmail. That's all I know about it. SendEmail, I give it some object that tells it who is it going to, what's the subject and the body line, but that's basically all I tell it. Tell it sendEmail. Okay. Now, unfortunately, because I'm saying new, I'm tightly tied to, well, this specific implementation of the email sender, right? So oftentimes, as far as dependency injection, the problem that we're trying to solve is I don't want to say new. Because as soon as I say new, this class knows about the other class, right? So what I'm going to put in instead there is something we call a dependency injection framework. So it might actually look something more like this. So I have my password reset helper. It's got some sort of variable to hold the email sender. It's got a constructor. This would be injection by constructor. I can say, okay, well, it needs, in order for the password reset helper to work, it has to have an email sender. So I'm going to take that in the constructor. When you call reset password, then I'll use this. So at this point, this class doesn't know anything about my email sender anymore. It doesn't know about how the emails are sent. Does that make sense? So I could easily pop in another implementation of that interface for testing purposes, or because the logic's changed on the email side, and it would still work. Questions? I definitely recommend reading this chapter more in depth. Going back and reading through chapter 3, because there's a few things here I'm skimming over as far as details go. Okay, so to inject those dependencies, where are we at? Yeah. So in a few chapters we'll come back to this and we'll talk about an inject, which is a framework that kind of does this for us. We really, really don't want to be building our own dependency injection framework. It's very hard to actually get it right, unfortunately. So there's a lot of code that's been, a lot of efforts that's been done to make these things. They're kind of an important thing, but I would recommend taking one off the shelf. Biggest one being Inject. There's another one that Microsoft's put out there. It's called Unity. So, but the textbook primarily works with Inject. Now that Unity what I'm talking about is not the Unity 3D, and it's not for games. It's not that Unity. Okay, so how do we get started with unit testing? So usually the first step to creating unit tests in Visual Studio is we need to create a separate project. So in our solution right now we have one project, which is the actual web application. We would go right click on the solution, add new project, we'd be adding a new unit testing project. Inside of that project is where we actually put our tests. So they're going to actually be separate. So the unit test code we don't ship with the actual website. It doesn't actually go live to customers. It's just something we use internally, which is where we stick it on another project. Okay. One note here. Let me just read this out because it's worth reading. So being able to perform unit tests. Unit testing is one of the benefits of working with the MVC framework. It isn't for everyone, and there's no intention of, he has no intention of pretending otherwise. If you have not encountered unit testing before, then I do encourage you to give it a try and see how it works. I do like unit testing and see it and use it in my own projects, but not all of them and not as consistently as you might expect. I tend to focus on writing unit tests for features and functions that I know will be hard to write and they're likely to be a source of bugs in deployment. In these situations, unit testing helps me structure my thoughts about how to best implement what I need. I find that just thinking about what I test helps throw up ideas and potential problems, and that's before I start dealing with actual bugs and defects. So one of those benefits of writing these tests is, again, kind of trying to take a look at where are those areas that we might have a problem and planning ahead for them. Writing tests, however, does come at a cost, right? It's more code you have to write. So there is a trade-off there between how much time do you spend on testing, how much time do you spend writing code, right? And usually the trade-off comes at, well, okay, this is going to take me, how long is this going to take me to write, and how many bugs do I think I'm going to have in it, right? And the more likely that I'm writing something, the more complicated what I'm writing is, or the more likely I know that I'm going to have bugs in this section of code, the more benefit I'm going to get out of writing tests for it, right? So if I'm doing something very, very simple, probably not worth running a test around. But if it's something fairly complicated, I probably should write some tests on it, and I probably should write them before I write the code, just to establish, well, it should behave for this kind of situation this way, or it should behave this way for this situation. Because once you start throwing millions of objects at something, it can be very hard to look at that result that's 10 pages long and say everything's correct, right? When you start throwing real world data at it.
Are you going to go more over like unit testing, like during this like next few chapters, or because we didn't really learn unit testing?
And that's okay. I'm not planning to spend a lot of time with it. I recommend reading through the book and seeing what they say. It's kind of not the most important thing this semester. It's something to be aware of, and if we get into code that's complicated enough to kind of merit testing it, then we can look at that. I'm not really going to dive into it very deeply. Fair forewarning. They will, just a heads up, as far as the written test and the hands-on test is concerned, unit testing will not be on there. So don't fret too much on that front. I think there is a question or two on the homework about test-driven development, but it's not going to be on the written test or the hands-on test.
Thanks for the test tips.
Huh?
Thank you for the test tips.
Mm-hmm. So what a normal unit test is kind of going to look like this. So I have on the outside, I have this test class, and you can see that it's kind of delimited. I've got this test class attribute that's up here, is what starts it off, right? And then within that, I have methods. Each of these methods is marked as a test method. Each of these test methods are what we call a test, right? That's the actual code that runs, and we say, at the end of that test, we say, did it pass or fail? Every unit test results in that result. It's either a pass or it's a fail. There's no in between. There's no, hey, this piece of code gets a C, If this code gets an A, this code gets an F, it's either pass or fail. That's it. Okay? So the way that we break up our tests falls into three groups, three kind of blocks of code. First, what we do is we say we arrange the scenario, we set it up. We say, what is the situation that's happening that I want to test? Where does things start? So I'm going to arrange, I'm going to set up a kind of test scenario. And then I'm going to go act, which is say, okay, now let's do the thing that I'm trying to test, right? So just to be clear, this code up here I'm not testing. I'm just assuming that this code up here works. The code I'm testing should 9 times out of 10 be just one line. So usually just call this one method and see if it works out. So we're going to call this method, change login name, and then we're going to go check, did it do what it should have. So we set up the scenario, which is, hey, we've got this fake repository for users. And I say, okay, this repository has one user in it. I've got my admin controller. It's going to get at that repository. I'm going to say the old login name for that user is Bob. New login name for that user is Joe. If I go change the login name, well, what do I expect? Not having seen any of that code, what do you expect that this has done? Change login. You expect that it's changed it from Bob to Joe. Right? Okay, so then we're going to say, the way that we verify that it's done what we want is we use these asserts. These asserts says, I want this to be true. So I want these two things to be equal. Now that I've done this, the user's login name should be Joe. If that's true, then the test keeps going. If it's false, this fails, I get a red X on my unit test. Okay? Then we go to the next one. We say, well, what else should be true? We also need to check the repository and say, did it submit the changes? Because if the controller made the changes but didn't submit them, didn't save them, well, the user's name hasn't actually changed, right? If it made the change in memory but didn't save it to the database, well, then that's not worked out. So if either of those two things don't happen, this unit test is going to show up in our Test Explorer as a red X. Otherwise, all this stuff passes. We get to the end. We're going to see a green. Does that make sense? So pass, fail. So that's the basic structure of any unit test that you write. Okay? Which is pretty flexible, right? Pretty flexible. That's how this sort of looks. Now, let me I'm going to open up the project for Chapter 3 so we can look at it in Visual Studio. Open project or solution, desktop. I'm going to go open here, Chapter 3, testing demo. There we go. So this is sort of the arbitrary project that they've created. So if I look at Solution Explorer, you'll see that there is one solution. It's got 2 projects in here. So testing demo is the name of the website, and then testingdemo.tests is where I have my unit tests. So if I look at testing demo, I can go see that there's this admin controller. Admin controller only does one thing right now. It knows how to change a login name, right? So here's the code for it. It says go fetch the user, change their login name, save the changes, right? Pretty simple. Most real-world code is quite a bit more complicated than that. But if I look at the admin controller tests, that's down here. So you can see that test that we just saw from the book. The way that I run that test, I go to View, and then I'm going to go to Test Explorer. Actually, I think that's under Test. Yeah, so Test. Windows Test Explorer. That'll open this window. I usually dock it over to the left side of my screen, but you can see the tests. Notice it's already picked up this test method, right? You can see it's in blue. Blue means that it hasn't run the test yet. If I want to run the test, I'm just going to click here. Great, all good, passed. What happens if I break this controller? Let me go back to the original controller. I'm going to say, well, let's comment out that line, because clearly that's an important line, right? Saving the changes. So let's see if my test is right, that should fail it. So I'm going to go save that, run the test again. It's going to show up red. And it says what failed. So I can click here, and it's telling me that this assertion here failed. So it'll tell me which assertion failed, so I can start to then track it down and figure out, oh, one of the changes I made to the code broke something, right? Because otherwise, if I didn't have this test here, I might not know that I broke something until either a tester or a user tells me that something's wrong, right? Okay, so that's the basic setup of how you get into those unit tests, is through that Test Explorer. That little run button is how you initiate. One other thing to note. So the whole point of unit test is to test a single class in isolation. Say, take this very, very small part of my code, test it, so I know where the bug is. In theory, it gives me a good way to isolate, well, the bug is in this class, right? The other thing to know about unit tests is they are written by software developers, right? 9 times out of 10, the person who's writing your unit test is going to be you. Same person that wrote the code. Simply by the fact that usually unit tests take a fair amount of developed, intricate knowledge of how it works in order to actually write them. The other side of things is what we call integration test. And that's where you start putting all these things together and you look at it from an end user perspective and write tests against it. That makes sense? So what we usually classify unit tests into something we call white box testing. White box testing, you can look inside of it, you know how the individual parts work, and you're the same person that could move those around if you find out that there's a problem. So you know the intricate parts. Black box testing on the other side, that's where you have no idea of the inner workings. You pretend that you don't know anything about, you say you don't know anything about how this machine works inside, but I know what the user experience should be. So usually unit testing falls into white box testing. Usually integration testing falls into black box testing. We usually want both. As a general rule, you want to be doing a bit of both. Integration testing is often done, however, by dedicated testers. So where the developers are usually the ones that write the unit tests, the testers, the QA engineers are usually the people that are going to do that integration testing. Now, depending on what company you work for, you may find yourself doing a little bit of both. That's not uncommon. So say you're trying to get your brand new version of the software out. You might find yourself doing a little bit of integration testing, but those are usually 2 separate teams. Okay? So that's a broad overview of Chapter 3. Again, I'd recommend to read it in detail. There's basically breaks into 2 things that we're talking about. Is A, first of all, what is the MVC pattern? And how is it different than maybe how you've seen code written before or other ways of writing code, right? And specifically, you want to look at and see, well, what are those advantages of writing it with MVC over writing it, say, ModelViewPresenter, right? What are those benefits? How is that different? And then the other part of this is, well, getting a little bit of introduction to testing. And as we kind of mentioned in chapter 1, that is one of the unit testing is and testing in general is one of the main benefits of MVC over forms, right? Forms are written in a way that automated testing of any kind was literally impossible. Whereas with MVC, it is very easy, right? It's relatively easy. There's nothing that it kind of gets in the way of like, okay, you can't test because of this is what Microsoft decided to do for the most part. Okay. That's what I have for today. What you have for assignments, if you're looking on Inside Rankin, see, we go under coursework. So what you have for remaining for this week, because tomorrow and Friday will be lab days. Homework 1C is due by the end of Friday, as well as lab sheet on 1A is due by the end of Friday. So those are the two things to work on for the next few days. Okay. So homework 1C is going to be largely theory. This is a written form. There's a bunch of written form, multiple choice, short answer, essay questions in there. That's going to be largely around the theory. And then 1A is going to have you do three different applications for them. Relatively simple. Let me go look at the attachment here so we can go look at those. So the first one is make a temperature converter. Take in Fahrenheit, convert it to Celsius and Kelvin. Simple as that.
So you want us to use, you want us to use Bootstrap on all of them?
Yes. Yep, use Bootstrap on all of them. This is obviously, this application is just going to be one controller. And what I'd like you to do is both of these under one solution, just under one project, because again, it's just going to be one controller, one view. So you have a temperature converter, you have an MVG calculator, you can both put those into the same project. And then the third lab in here is to make a version of your portfolio using MVC. So most of that's going to be static. The one thing that's going to be somewhat dynamic using the MVC is that I want you to put a contact me form on there that will allow them to get in touch with you. Does that make sense?
Does that have to work?
The contact me form does need to work.
Does that mean we have to keep all the changes we made to our Gmail?
Huh?
Does that mean we have to keep all those changes we made to our Gmail account and stuff?
That or use a different provider for email. That or use a different provider. So the only change you got to make for Gmail is to just flip the box, turn the box on. Right? Yeah. So either go through Gmail or use another provider that you find online for that. But that's the one we covered. Any questions there? That's your kind of assignments for Thursday and Friday. So if you want to get started on the homework, feel free. Yeah.